All right, today we are going to continue along with some work here in trigonometry, although we're going to move away from the calculator a little bit. And today this is kind of going to be a two-part lesson here. So we'll do a video today, and then the next day I assign something. I'll put another shorter video up. We'll call this 8.9 part 1. We're going to talk about Pythagorean identity proofs today. Okay, so this will be a little bit of a longer video. Feel free to watch it in multiple parts if you'd like. We're going to go through like 6 different problems today. Some of them take a little bit longer than other ones. But before we can get into any of those problems, let's talk about a couple identities that we already know, and then one new one that I've mentioned, but I'm going to mention it again right now, and then we'll get into some problems, okay? So first thing that I want to mention here, you guys already know this, but tangent of theta is the same thing as sine of theta over cosine of theta, which means anytime we see a tangent of theta, if we want to, we can replace it with this. You'll see what I mean by that as we get going. And cotangent of theta is the same thing as cosine of theta divided by sine of theta. Okay, so anytime we see a cotangent of theta, if we'd like to, we can replace it with cosine over sine. Okay, so you already know these. Another one that you already intuitively know, but we might not have put a name to, are the reciprocal identities. Okay, I'm just going to use IDs for that. So here are your reciprocal identities. Cosecant of theta is just sine flipped over. So that means if we take sine, which is sine of theta divided by 1, and flip it over, we get 1 over sine of theta. Okay, if we've got secant of theta, this is the same thing as 1 over cosine of theta. And you probably won't need to use this, but we'll note it anyways. Cotangent of theta is the same thing as 1 over tangent of theta. Okay, so if you ever need to use these, you definitely can. You will see times where we'll need to use those today. Okay, all right. Last big set here, and then you can do any problem that I give you, is the Pythagorean identity. Okay, and the Pythagorean identity comes directly from the Pythagorean theorem. Okay, I laid this out when we were doing the law of cosines, but I'm going to go through it again right here. If I have a right triangle and I call this angle theta, okay, and I'm labeling the sides, this would be the opposite side, this would be the adjacent side, and then this would be the hypotenuse. Okay, and if I wanted to use the Pythagorean theorem to identify the sides of this triangle, it would look like this: O squared plus A squared equals the hypotenuse squared. Okay. Now the Pythagorean identity goes a little bit further here, and what it does is it divides both sides of this equation by h squared, which means the right side of the equation is now going to be 1. Okay, and the left side of the equation can be written as O squared over h squared plus a squared over h squared, because I'm dividing everything by h squared. Okay, which, going a little bit further, I can pull that squared out of both of these, and this is what I get. Okay, and we've learned that O over h is the same thing as sine of theta, so this is sine of theta squared. A over h is cosine of theta, so this is cosine of theta squared. And what this identity says is that when I add sine squared of theta plus cosine squared of theta, I will always get the number 1. Okay. Now this is all you need to know for the Pythagorean identity, although I am going to make a note here. If you know this, then you can also make this statement: cosine squared of theta equals, if I were to subtract sine squared of theta from both sides, I would get 1 minus sine squared of theta right here. Okay, this is a good thing to know as well. Okay, because anytime I see a cosine squared, I can replace it with 1 minus sine squared of theta. And along the same line, sine squared of theta, if I wanted to isolate that, I could subtract cosine squared of theta from both sides. Okay, so these are also the Pythagorean identity, although it's a little bit of algebra to get either cosine squared of theta or sine squared of theta isolated. Okay, so this is the big identity for today, though. We're going to use this a lot, or these alternative forms. So let's jump right into a problem. Okay, now when we do these, what we're going to be doing are proofs. Okay, which I know people don't like proofs. Okay, but what we're going to do here is we're going to prove the following statement. Okay, prove the following statement. All right, in other words, what we're going to do is transform the left side to look exactly like the right side. But a big part of this is don't touch the right side. Okay, don't touch the right side. Okay, so we're going to keep the right side the exact same, and all we're going to do is we're going to use those identities that we just mentioned to help take the left side and change it into the right side. It would almost be like me saying, prove that 3 times 2 plus 1 is equal to 7. Okay, we're going to keep this 7 the exact same, but if I wanted to show this in steps on the left side, what I would say is, okay, 3 times 2 is 6, so this becomes 6 plus 1, and 6 plus 1 is 7. And now I've transformed the left side to look exactly like the right side without touching the right side at all. Okay, so that's the general idea here when we do these problems. All right, so let's jump right into one. Like I said, we're going to do 6 of these today. Some of them are super simple, other ones take a little bit longer. We'll start with a few that are really easy to get us going, and then we'll go into the harder ones. But for our first one, let's try this. Secant of theta. Sometimes I'll use theta, sometimes I'll use x, kind of just depends on the problem. But I've got secant of theta times cosine of theta minus cosine squared of theta is equal to sine squared of theta. Okay? All right, so let's begin with this. I know that secant of theta is the same thing as 1 over cosine of theta. We just mentioned that. Okay, you never want to do too much in one step. Okay, you only want to do like one thing at a time. All right, because if you got a bunch of crap in the middle that none of it matches up with, and I can't follow what you're doing, and none of it matches up, and then all of a sudden you end up with the same thing on both sides of the equation, you're not going to get credit for that. Okay, so right here I can clearly see I'm changing secant of theta into 1 over cosine of theta, and then we know that cosine of theta divided by cosine of theta is just going to give me 1. Okay. Now, you do not need to write the right side of this equation every time because I know when I'm done, I should get sine squared of theta. Okay. So I'm not going to keep writing this here. It's just going to be the same thing the entire time. But what I have learned based on the Pythagorean identity, if you remember, is that anytime I see a 1 minus cosine squared of theta, that can be replaced with sine squared of theta. Okay, so now that I've got it to here using the Pythagorean identity, I'm going to replace this with sine squared of theta. Now the left side is the same as the right side. So the way that I'm going to finish one of these problems is I'm going to get it to where I have the same thing on both sides, and I'm going to put a little check mark to signal that I am done with the problem. Okay, so we went through step by step here. We first changed secant of theta. We did some multiplication. This became a 1. And then 1 minus cosine squared of theta is the same thing as sine squared of theta using the Pythagorean identity. Okay, so we have proved this statement to be true. All right, next up, try another a little bit shorter one here. Same directions here. I'm just going to say prove. Okay, and we have sine squared of theta minus cosine squared of theta equals 2 sine squared of theta minus 1. Okay. Now, one thing I want us to notice on this side, and this is a good strategy for when you're first starting out a problem, look at what you see on the left side and look at what you see on the right side. Okay. On the left side, we see a cosine squared of theta. I do not see a cosine of theta anywhere on this side of the equation. Okay. So this should be a good hint to me. Is there a way that I can change this? Okay, can I change this? The only thing that I see over here are sines. Okay, I see a sine squared. Is there a way that I can change this into only using sines? And in fact, yes, there is. Okay, if I go back to the Pythagorean identity, if I want to get rid of a cosine squared of theta, I can replace it with 1 minus sine squared of theta. Okay, so that's exactly what I'm going to do here. Now, I need to be very careful when I do this because I must make sure that I put parentheses where the cosine squared of theta would be, because I'm going to replace that with 1 minus sine squared of theta. Okay. From here, this is just simple algebra. I'm going to go ahead and distribute this negative sign. So on my next step, I get sine squared of theta minus 1 plus sine squared of theta, because the two negatives make a positive. Okay. And now I've got sine squared of theta plus sine squared of theta, which gives me 2 sine squared of theta minus 1, which is in fact equal to 2 sine squared of theta minus 1, which is what I was trying to prove. So I am now done with my proof, and I can give myself a little check mark here to finish out the problem. Okay, so I looked at the left side, looked at the right side, noticed there was something here that I didn't see over here. So I checked to see if I could replace it. I could replace this using the Pythagorean identity with 1 minus sine squared of theta. And then from here, it was just a matter of us distributing and combining like terms to get the left side and the right side to look just like each other. Okay. All right, another problem here. Each one's going to be a little bit different. And when we're done with this video, we'll kind of summarize with a list of strategies. So that should help us out some, so that we have an idea of some things that we can try every time that we get one of these problems, right? Okay, so for this problem, let's try tangent squared of, I'll use x this time. So tangent squared of x minus sine squared of x equals tangent squared of x times sine squared of x. Okay. All right. One strategy that you're going to hear me say quite a bit is whenever you're doing these, anytime that you see a tangent squared of theta, go ahead and change that into, go ahead and change a tangent squared of theta into sine squared over cosine squared. Okay, so I'm going to go ahead and rewrite this as sine squared of x minus, or sorry, sine squared of x over cosine squared of x minus sine squared of x. And I'm sorry, we'll leave it just like that. Okay, and from here, sorry, so that I'm color coding this so you can see exactly what I'm changing every time. Just go ahead and just do this for now. Okay, we're trying to prove that these are equal, so I'm gonna put a question mark over that equal sign for now. And now what I see here is I've got two different fractions. Okay, I've got a fraction here, and then I've got a fraction here. Okay, and a good strategy anytime you have two fractions and you're trying to add or subtract them is to find a common denominator. Okay, find a common denominator. All right, and the common denominator between these two fractions is going to be cosine squared of x. Okay, cosine squared of x. So if I'm rewriting these with a common denominator, what I'll see here is, okay, this already has a cosine squared of x, so I'm going to keep the top of this one the same. Okay, and this one only had a 1, so I multiplied in a cosine squared on the bottom, which means I also need to multiply in a cosine squared of x on the top. Okay, so I found a common denominator here, which is good. Okay, and now what I see from here moving forward is that both of these terms actually have a cosine squared of x. Okay, both of these have a cosine squared of x. So what I'm going to, or sorry, not cosine squared of x, both of these have a sine squared of x. So what I'm going to do is I'm going to factor out that sine squared of x. Okay, which when I'm done here gives me sine squared of x times 1 minus cosine squared of x, all divided by cosine squared of x. Okay. Now this is good because now what I've done is, this was a subtraction problem at first. Now I've turned this into just one thing times another thing. Okay, so let's see if we can split this up at all. I'm going to go ahead, and we know that, for example, if you're doing something like 3 times 2 over 5, this is the same thing as 3 over 5 times 2 over 1. Okay, because 3 times 2 gives me the top and 5 times 1 gives me the bottom. So I'm going to try something similar to that here, and I'm going to go ahead and I'm going to split this up and write it as sine squared of x over cosine squared of x times 1 minus cosine squared of x. If you want to, you can put over 1. Okay, I'm going to split this up here. And now the top will be this times this, which is what we have here. And cosine squared of x times 1 gives me cosine squared of x. And now from here, we can finish this problem all in one step. All right, we can finish it all in one step here because we know that sine squared over cosine squared of x is tangent squared of x. Okay, times, and we've also learned that by the Pythagorean identity, we can replace a 1 minus cosine squared of an angle with sine squared of that same angle. Okay, so here I have 1 minus cosine squared of x. I can replace that with a sine squared of x. Okay, and that is in fact what we were trying to prove here, that this is equal to tan squared of x times sine squared of x. So now that I've got the same thing on both sides, go ahead and put a check mark. Okay, so I'm done with this problem. So if we think about what we did here, first thing that we did was we replaced the tangent with sine over cosine. Okay, we found a common denominator. Okay, we factored out a GCF. And then from there, we were just taking a look at this and seeing what we needed to prove on the other side. Since there was a tangent here, I noticed I had a sine squared on top and a cosine squared on bottom. So I could go ahead and rewrite that as tangent squared of x, and then what was left over, I could use the Pythagorean identity to change that to sine squared of x, okay? All right, another problem here. Let's go ahead. I don't know if I actually wrote the directions on this problem. We'll say prove again. Okay, and same thing here. We're just going to say prove. Okay, and our statement this time is going to be cosine of theta over 1 plus sine of theta. Okay, plus 1 plus sine of theta divided by cosine of theta is equal to 2 times secant of theta. Okay. All right. Once again, I have two fractions, so I'm going to go ahead and I'm going to find a common denominator. Okay. Common denominator on this one, there is nothing in common between these. So I'm going to write this as 1 plus sine of theta times cosine of theta. Okay, and I need to think about what I'm missing on both of these. Okay, so here I have cosine of theta, on the bottom here I have a 1 plus sine of theta. I'm multiplying in a cosine of theta, which means I need to multiply it on top as well, which makes this a cosine squared of theta. Okay, and then right here I had a cosine of theta, but I'm multiplying in another 1 plus sine, which means I need to multiply the top by 1 plus sine, which turns this into 1 plus sine of theta times itself, another 1 plus sine of theta. Okay, so I'm trying to see if this is equal to 2 secant of theta. Now, one thing that you need to be careful of here is you got to make sure that you distribute correctly. Okay, distribute this correctly. All right, so let's go ahead and be very, very careful on this step. Write everything else as it is. Okay, and let's do some distributing here. So 1 times 1 is 1. Okay, this is going to be 1 times sine of theta, which is sine of theta, and then another sine of theta times 1, which is another sine of theta. So if I do 1 sine theta plus another sine theta, now I have 2 sine of theta, and then sine of theta plus sine of theta gives me sine squared of theta. Okay. All right, so I distributed this out, I FOILed this out. Now let's take a look at the top. I now have a sine squared of theta and a cosine squared of theta. Okay, let's rearrange this sum. So now I've got, if I wanted to rewrite this in a different order, I'd have sine squared of theta plus cosine squared of theta plus 1 plus 2 sine of theta, all divided by 1 plus sine of theta times cosine of theta. Okay. Now, as I just mentioned, this is the Pythagorean identity. This becomes a 1. Okay, that's the heart of what we're talking about today, is that anytime you see something like that, you can replace it with 1. And now I have another 1 here, so 1 plus 1. I can now rewrite the top of this fraction as 2 plus 2 sine of theta divided by 1 plus sine of theta times cosine of theta. Okay, and if you notice here, both of these terms on top have a 2. So if I'd like to, I can factor out this 2, which gives me a 1 plus sine of theta left over, which lights should be going off in your head right now. This is really nice because what else do we see on the bottom? We also see a 1 plus sine of theta there. Okay, so now what I can do is I can divide that 1 plus sine of theta out of the top and the bottom. I'm left with 2 over cosine of theta. Okay, and if we've learned that 1 over cosine of theta is the same thing as secant of theta, then that means 2 over cosine of theta must be the same thing as 2 secant of theta And this is convenient because that is exactly what we were trying to prove in the first place, is that this was equal to 2 secant of theta, okay? So going through our process here, we have now proved this. So if we're kind of reviewing what we did here, we found a common denominator, okay? We distributed this out. We used the Pythagorean identity, okay? Combined like terms to make this a 2. Then we factored out the 2, divided this out, and then 2 over cosine was the same thing as 2 times secant of theta, okay? That was one of the little longer ones that we'll probably see here, but it involves a lot of good strategies, okay? All right, a couple other ones here, which I don't think are actually as long as number 4. That's probably the longest one we've seen. So let's knock these out, and then we'll kind of finish by summarizing with a list of strategies. Okay, so let's try this. So for this one, we're going to try sine of theta plus cosine of theta times tangent of theta plus cotangent of theta equals secant of theta plus cosecant of theta. I'm running out of space there, so I'll go down to the next line. Okay, so as I mentioned in, I think it was 2 problems ago. Yeah, 2 problems ago. Anytime you see a tangent or a cotangent, go ahead and change it into sines and cosines. So first thing that I'm going to do here is I'm going to keep this first set of parentheses the same, but I'm going to rewrite tangent and cotangent as sine of theta over cosine of theta, and then cotangent I'll rewrite as cosine of theta divided by sine of theta. Okay. And I'm going to keep working in this set of parentheses because now what I have over here is I have 2 different fractions, okay? So I'm just going to keep this the same for right now. But in this second set of parentheses, I'm going to go ahead and rewrite this as one big fraction with common denominators. Common denominator here, cosine of theta times sine of theta. And then let's think about what these need. This had a cosine. I multiplied in a sine, so I got to do that on top. So this now becomes sine squared of theta. Okay, this one had a sine of theta. I multiplied in a cosine of theta. So this becomes cosine squared of theta. Okay. And once again, the Pythagorean identity says that I can now replace this with a 1. Okay. So if I'm moving on to my next step here, now what I have is sine of theta plus cosine of theta times 1 over cosine of theta sine of theta. Okay, now let's just go ahead for simplicity purposes and put all of this on the same fraction. So this is going to give us sine of theta plus cosine of theta times 1. So we'll just keep it the same. And then on the bottom here, we'll have 1 times cosine of theta times sine of theta. Okay, now this leaves us kind of in an interesting spot because on the other side of the equation, we have 2 separate terms. Okay, secant of theta plus cosecant of theta. Here, though, we just have one big fraction. Okay, one big fraction with a big denominator. Okay, so I always use this simple example here to help students in a situation like this. Okay, if I wrote this on the board, this is one big fraction. Is this the same thing as me splitting up this fraction into 3/4 plus 1/4? Okay, let's check. Well, 3 plus 1, this is 4 over 4, which is 1. Okay, and then over here, we know that when we have the same denominator in both fractions, I can add 3 plus 1, gives me 4/4, which is equal to 1. Okay, so I don't really need this question mark here. So what does this tell me? It means I can split up a fraction using the denominator. I can rewrite this as 3 over 4 plus 1 over 4. As long as I keep the same denominator on both of these, this is still a true statement. Let's try that here and see what happens. Okay, so in other words, I'm going to write this as sine of theta divided by all of this denominator, okay, plus cosine of theta divided by all of this denominator. Okay, and now from here, pretty easy. Sines divide out, cosines divide out. This leaves me with 1 over cosine plus 1 over sine of theta, okay, which is also known as 1 over cosine is the same thing as secant of theta. and 1 over sine is the same thing as cosecant of theta. Okay, so when I'm finished here, this is exactly what I was trying to get, secant of theta plus, sorry, it's getting a little weird here because it's a long page, secant of theta plus cosecant of theta. Okay, so as I started out here, I changed the tangents and cotangents, found a common denominator, used the Pythagorean identity. Okay, but a new strategy that we saw here, once I multiplied these two fractions together, was I took this big fraction that had addition and I split it into two littler fractions. Okay, and by doing that, that allowed me to get to what I saw on the right side of the equation. Okay. All right, one more here, and then we will be done. We'll summarize all of our strategies here, and then we'll be done with this video. Okay. All right. So example 6. Once again, we are proving. Okay, and this time we have cosine squared of theta divided by 1 minus sine of theta. Sorry. Equals 1 plus sine of theta. Okay. Now, as I mentioned at the beginning, or on one of our earlier problems, when you see over here that this only has sine of theta and this has a cosine squared of theta, this is a good indication for you. Let me see if I can change this to something that only involves sine of theta. Okay. And we know from the Pythagorean identity that cosine squared of theta is the same thing as 1 minus sine squared of theta. Okay. So what I'm going to do is I'm going to change this numerator into being, sorry, I'm not going to rewrite that right side every time, but I'm going to change that numerator into being 1 minus sine squared of theta. Okay. Now, from here, if you remember from back in Algebra 1 and Algebra 2, when you see something called a difference of perfect squares, what that means is you have something that looks like a squared minus b squared. Okay. And we've learned that that can be factored as a plus b times a minus b. Okay, so in other words, if you had something like x squared minus 9, this would be the same thing as x plus 3 times x minus 3. Okay, so let's see if we can use that on the numerator here of this fraction. 1 minus sine squared, this is a difference of squares. Okay, it's a squared minus b squared. The a value is 1, so this becomes 1 plus sine of theta times a minus b, which would be 1 minus sine of theta. Okay, so I went ahead and I factored the top of this, and this is helpful for me because I now see that I can cancel these out. And when I'm done, I get 1 minus sine of theta equals 1, or I'm sorry, when I'm finished, I get 1 plus sine of theta equals 1 plus sine of theta, which is what I was trying to get all along. So I've finished this problem. So if you think about strategy here, we've done this earlier. We changed the cosine squared, or we changed one part of a sine squared or a cosine squared into another form of it that does not involve what we originally had. We've done that already, but what was new here was we factored this as a difference of perfect squares. Okay. So let's finish up real quick by summarizing some of these strategies. And then we will be finished for today. So strategies that we've seen thus far. Okay. One major strategy is anytime you see a tangent or cotangent, I've told you to change it into sine and cosine. Okay, and that's a great strategy for starting out most of these problems. Okay, so anytime you see those, go ahead and change them into sine or cosine. Okay, all right, another one, if you have two fractions, you should find a common denominator. Okay, we probably did that on at least 3 of these problems. We had 2 different fractions. In order to add or subtract them, we had to find a common denominator. Okay, another strategy that you might use a lot. Okay, if you see that 2 terms have something in common, factor out the GCF, or if it helps you, like we saw in the previous problem, if you have something like this and it helps you, go ahead and factor a difference of perfect squares. I'm not saying that you need to do that all the time, but if it's helpful, and that takes some analysis on your part, but if it is helpful, go ahead and do it. Okay. Another thing that we've seen, distribute. Okay, if it is useful for you, as it was in, I believe it was number 4, okay, when we were working with this 1 plus sine times 1 plus sine, we distributed this out, and if we hadn't done that, it wouldn't have allowed us to do the rest of the problem. So if it is helpful for you, and again, this takes analysis, go ahead and distribute, okay? And then the fifth and final strategy that I often tell kids is if you have one term, but the right side of the equation says it needs to be 2 terms and it's a fraction and you have addition or subtraction, go ahead and split it up. Okay. The way that I write that is like if you have something like this and it's helpful, go ahead and split it up into 3/4 plus 1/4 if you need to take one term and turn it into 2 terms. Okay. So that's all I've got for us right now for today. I'll put some homework up online for you guys to practice some of these, and then we will actually, for our next lesson, I'll do another shorter video that has a couple more problems, and then we'll continue to practice. And then after that, I think we might be done with most of our trig material. All right, I'll see you later, guys. Bye.